Okay, now I'm going to be answering a question that was asked on my channel, which which is not related to a past paper question, and I don't normally do these kind of questions, but I'm going to do this seeing as things are a bit quiet, given the coronavirus at the moment, and normally tomorrow I think there's an exam. There will be exams these days, and I would be like chock-a-block answering past paper questions for people. So I wouldn't really have the time to do what I'm doing now. So I'm going to do this just, this student was asking this question. Can you solve this question? In a geometric sequence, the sum of the first three terms is 26. The sum of the last three terms is 702. Find the common ratio. Now the student mentions the answer is 3, but I don't know the steps to solve it. Okay, so now it's a geometric sequence, which is of the form where you have the first term and then you multiply that by the common ratio to get the second term. So the first term would be a, and the second term would be a times the common ratio, and the third term would be a times the common ratio times the common ratio, and the sum of those first three terms is 26. Okay, so we don't know the first term, we don't know the common ratio, we don't even know how many terms are in the sequence, but we know that the sum of the first three terms is 26. That's definitely true. Okay, let me call that equation 1. We also know that the sum of the last three terms is 702. Okay, so we don't know how many terms there are, so I can't do something with the numbers here. I can't say a times r to the power of something, because I don't know how many terms there are. So what I'm going to do is I'm going to use a general form. The last term is a times r to the power of n minus 1. That's the nth term of the sequence. That's the last term of the sequence. The one before that will be a times r n to the power of minus 2. And the one before that will be a times r to the power of n minus 3. And I know that the sum of those last three terms is 702. So there's the two basic equations I've got, which I need to solve simultaneously. Okay, now in order to solve these equations simultaneously, there's basically three things that we don't know, and there are two equations. So in normal cases, it might not be possible to find the values of these three variables. However, because we know something for sure about n, that will help us in solving this equation, or this pair of equations, because we know that n is definitely a natural number. It's definitely a natural number, meaning it has to be 1, 2, 3, 4, 5, 6, 7, 8, something like that, and it must be a whole number. It can only start from 1. It must be a whole number, because it's like the position of each term in the sequence, and the first term of the sequence starts at 1. The second term is the second term. You don't get a sequence with the n equals 1.5, or n equals 0, n equals minus 1. No. The first term of the sequence is its first term, and then the next term is its second term, and so on. So these numbers here must be whole numbers starting from 1, positive. We also know that the number of terms in the sequence must be greater than or equal to 4. You can't have less than 3 terms in the sequence, because otherwise it wouldn't make sense, the sum of the first 3 terms. You can't even have 3 terms in the sequence, because the sum of the first 3 terms and the sum of the last 3 terms would be the same sum, because they will be the same terms. So the least number of terms in the sequence is 4. You could have more terms than that. So with these two conditions here, that might help us to actually take a guess once we've got close to the answer. So what I'm going to do is I'm going to manipulate these algebraically and then try to solve. So now for this, I'll take out a as a common factor. So I have 1 plus r squared times a equals 26. Okay, now for this one, what I'll do is I'll take a as a common factor, and then that will leave me with this, r to the power of n minus 1. Now when you have the power subtracted, it means there was a division. So the origin of this was r to the power of n divided by r. And the origin of this was r to the power of n divided by r squared. And the origin of this was r to the power of n divided by r cubed. Those will give me the same as those. I've just taken a out as common before. and that's equal to 702. Now I can simplify this a bit further by taking out r to the power of n as common. Then I've got 1 over r plus 1 over r squared plus 1 over r cubed, and I've got 702. And now what I can do is I can combine this together into one fraction. If I do that, you see something interesting happen now. If I combine these into one single fraction with the common denominator, now the LCM of the denominators is r cubed. So if I think about this, I have to multiply by r squared, so that has to be multiplied by r squared, multiplied by r, so that must be multiplied by r, and this has to be multiplied by 1, so that's multiplied by 1. You'll notice that I've got something which will help us here, because this is the same as that. Okay, so what I can do is I could replace the r squared plus r plus 1 with 26 over a, because 1 plus r squared is equal to 26 over a. So if I take the 1 plus r squared over here and replace it with 26 over a, I'm left with a r to the power of n times, now I'm going to replace this with 26 over a, so it's like 26 over a, that's that part, then I've got the r cubed there already, and that's equal to 702. Now it's looking a bit more friendly. We can cancel out the a's and we can divide both sides by 26. So you have r to the power of n over r to the power of 3 is equal to 702 over 26. Okay, now taking the calculator, I can divide 702 by 26. And that gives me 27. So I can rewrite this as well as r to the power of n minus 3 equals 27. Now, getting this far will help us, because I know n must be a positive integer, and it must be greater than 4. So I can think of just by using exponential equations of ways to solve this. I know that, for example, r, if it's 27, then this would work. Also, if r is 3, this would also work, because 27 can be expressed as 3 to the power of 3. In this case, n would equal, you'd say n minus 3 equals 1, so n would equal 4. In this case, n minus 3 equals 3, so n would equal 6. So these are two possible. If r is equal to 27, that's one possible answer. If r is equal to 3, that's another possible answer. So these are two possible answers which would solve our question. Okay. If the question was more specific and said, for example, the first term has to be an integer or something, then we could choose between them. But both of these will work, and I'll show you how both of these work. Let's start with the simplest one, r equals 3. Now, if r equals 3, let's go back to what we did in the beginning to kind of set up the equation. Oh, what's going on here? Not working very well, is it? Okay, so we got to this stage here. We had a times 1 plus r squared equals 26. So let's use that when r equals 3. So you have a, and you had 1 plus r squared, that's a 1 there, is equal to 26. Okay, so if r equals 3, that will be a times 1 plus 3 plus 9 equals 26. So that's 10 plus 3, 13. So 13a is equal to 26. So a is equal to 2. So in this case, if r is 3 and a is 2, our first term would be 2. Then our second term would be 2 times 3, which is 6. And our third term would be 2 times, so you have 2, and then 2 times 3, and then 2 times 3 squared. Okay, 2 times 3 squared is going to be 18. Okay, what is the sum of those three terms? If you add them together, you get 2 plus 6 plus 18 gives us 26. So that works. And remember, when r equals 3, that's when we had 6 terms. So the sixth term would be a r to the power of 5. So AR to the power 5, and the fifth term will be AR to the power 4. And the term before that, which would be the fourth term, sixth, fifth, and fourth term, will be AR to the power 3. And that will give us, you will have A, which is 2 times 3 to the power 5, plus 2 times 3 to the power of 4, plus 2 times 3 to the power of 3. Now let's see what that gives us. It should give us 702, which was the sum of the last three terms. 2 times 3 to the power of 5. Okay, plus 2 times 3 to the power of 4, plus 2 times 3 to the power of 3. Yes, it gives us 702. So 3 actually does work. Okay, and that's one solution. We could also try when r equals 27. Now remember, when r equals 27, the number of terms was 4. Okay, when r equals 27, the number of terms was 4. Okay, so let's use that. First of all, we need to use a times 1 plus r squared equals 26 to find what the first term is. So you have a 1 plus 27 plus 27 squared equals 26. So a is going to be 26 divided by the sum of those. Let's work out what those are. You've got 1 plus 27 plus 27 squared. That gives us 757. Okay, so let's see if it works. The first term is going to be 26 over 757. Now this should work because we got it exactly from here, but just to make sure, that's the first term. Plus, second term, 26 over 757. Oops, what am I writing down? 757 plus 757 times the common ratio, which is 27. And the third term, 26 over 757 times 27 squared, and that should give us 26. Let's just confirm that. So you got 26 over 757. Now I'll just take that as a common factor and multiply it by 1. Oops, that's not how I do it. Multiply it by 1 plus 27 plus 27 squared, and that gives us 26, which it should. And the last three terms, remember this time there were 4 terms. So we have AR to the power of 3 plus AR to the power of 2 plus AR. Those would be the last 3 terms. So you have A, which is 26 over 757, sorry, times, and I'll take that as a common factor. I'm going to have R cubed, which is 27 cubed, plus R squared, which is 27 squared, plus 27, and hopefully that should give us 702. So we got 26, let me just change that to 27 cubed, and change this to 27 squared, if I can, 27 squared, and this one should be 27. Yep, so you have 27 cubed plus 27 squared plus 27 times 26 over 757 equals 702, which is proving that if r equals 27 and there's 4 terms, then that works. You have the first 3 terms adding up to 26 and the last 3 adding up to 702. And if r equals 3 and there are 6 terms, then you get the same sum for the first 3 and the last 3 terms. So I hope that answered your question and the method was clear to you. Thank you for watching.